Hello students, myself Hena Shah, Assistant Professor at LG Institutes of Engineering and Technology. Today we are going to solve few more examples of partial derivatives. So let us begin with the first example. If u is equal to log x cube plus y cube plus z cube minus 3xyz, then prove that del by del x plus del by del y plus del by del z whole square into u is equal to minus 9 upon x plus y plus z whole square. So let us begin with its solution. Firstly, we will simplify this, that is del by del x plus del by del y plus del by del z whole square into u. We will write it as del by del x plus del by del y plus del by del z into del by del x plus del by del y plus del by del z into u. We have split this term. Now what we will do is we will take this u inside this term. So what will happen? Del by del x plus del by del y plus del by del z into del u by del x plus del u by del y plus del u by del z. Now we will name this term as v, right? So v is equal to del u by del x plus del u by del y plus del u by del z. So now we will first find del u by del x, then del u by del y and del u by del z and add the three terms and then apply this term. So let us begin to find del u by del x, where u is log of x cube plus y cube plus z cube minus 3xyz. Firstly, we will differentiate u with respect to what? X, then y and z. So del u by del x is equal to, in order to find del u by del x, we will keep what? Which term constant? Y and z as constant. So keeping these two constant, our derivative of this will be derivative of log, that is 1 upon x cube plus y cube plus z cube minus 3xyz. Now applying chain rule, derivative of this term will be equal to derivative of x cube will be equal to 3x square. Derivative of this will be equal to 0 as it is constant. Derivative of this also will be equal to 0 as it is constant. Next derivative of this 3yz is constant, so keep it as it is, and derivative of x will be equal to 1. Similarly, find del u by del y. In this you have to keep x and z as constant. So keeping x and z constant, you will get answer as 3y square minus 3xz upon x cube plus y cube plus z cube minus 3xyz. Similarly, find del u by zz. So in these which terms you have to keep constant? You have to keep x and y constant. Keeping x, y constant, find del u by del z. So del u by del z will be equal to 3z square minus 3xy upon x cube plus y cube plus z cube minus 3xyz. Now we have to add these three. So on adding, we will get v is equal to del u by del x plus del u by del y plus del u by del z is equal to 3x square minus 3yz upon x cube plus y cube plus z cube minus 3xyz. Then put del u by del y, then put del u by del z. Add these three. So on adding and taking 3 common, you will get 3 times x square plus y square plus z square minus xy minus yz minus zx upon x cube plus y cube plus z cube minus 3xyz. Now we will simplify this term. As we know that x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. You must know this formula. Now replace this formula in this term. So finally your v will be equal to, on simplifying, 3 times x square plus y square plus z square minus xy minus yz minus zx upon x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Now you can see that these two terms get cancelled out. So finally the answer of V will be equal to 3 upon x plus y plus z. Now again we'll begin with our LHS, which is del by del x plus del by del y plus del by del z whole square into u, which was simplified as del by del x plus del by del y plus del by del z into v. Now put the answer of v, which is 3 upon x plus y plus z. Now what we have to do? We have to do the derivative of this term with respect to x, y and z. So let us do the derivative firstly with respect to x. So derivative of 1 upon x is equal to minus 1 upon x square. We know this. So derivative of this term will be 3 upon x plus y plus z whole square and minus. Why? Because we are keeping firstly y and z constant. Similarly, do the derivative of this with respect to y. So here what you will keep constant? X and z, and again apply this formula. So answer will be minus 3 upon x plus y plus z whole square. Right? Again apply the derivative with respect to z, keeping which terms constant? X and y. So again the answer will be minus 3 upon x plus y plus z whole square. For this you had kept y and z constant, right? In this you had kept which terms constant? X and z, and for last you had kept x and y constant. So on simplifying you will get del by del x plus del by del y plus del by del whole square into u is equal to minus 9 upon x plus y plus z whole square, which is your desired answer. Next, let us move on to our next example, that is, if theta is equal to t raised to n into e raised to minus r square upon 40, then find n so that 1 upon r square into del by del r of r square times del theta by del r is equal to del theta by del t. So you have to compare these two and then find the value of n. So firstly, let us begin with its solution. Here theta is equal to t raised to n into e raised to minus r square upon 40. So let us differentiate theta partially with respect to t. So firstly we will solve our RHS. So let us begin to find del theta by del t. So here we have to apply u-v rule of derivative, u into v rule, right? So what we have to do is firstly keep this term as constant, that is e raised to minus r square upon 40 is constant, and find the derivative of t raised to n. So derivative will be equal to n into t raised to n minus 1 plus, now you have to keep t raised to n as constant, keep it as constant, and do the derivative of e. So derivative of e raised to minus r square upon 40 will be e raised to minus r square upon 40. Now apply chain rule on this term. So while applying you have to keep which term as constant? R will remain as constant, right? So keep r square as it is and 4 as it is. Derivative of 1 upon t will be equal to derivative of 1 upon t will be equal to minus 1 upon t square, right? So minus minus plus. So finally it will be r square upon 4t square. Now what you have to do is you have to take out e raised to minus r square upon 40 common. So on taking out common you will get del theta by del t is equal to e raised to minus r square upon 40 n into t raised to n minus 1 and in this term what we have done, we have written it as t raised to n minus 2 into r square upon 4. Now let us go to our LHS part. So in LHS, firstly what we will find is, we will find del theta by del r just. So while finding del theta by del r, you have to keep t as constant. Which term as constant? T as constant. So while keeping t as constant, t raised to n will remain as it is. Just do the derivative of this term with respect to r. So derivative of this will be e raised to minus r square upon 40. Now do the derivative of this with respect to r using chain rule. So derivative of r square will be 2r. So answer will be t raised to n into e raised to minus r square upon 40 into minus 2r upon 40. So 2 will get cancelled out. So finally what will remain? 2. Now take out minus 1 upon 2 common and multiply with r square. So on multiplying, what you will get? R square del theta by del r will be equal to minus 1 upon 2 and t raised to n minus 1. We have written this as t raised to n minus 1 r cube into e raised to minus r square upon 40. Now what we have to do? The derivative of this term with respect to r. So we have to differentiate this again with respect to r. So now let us differentiate. Again keep which term constant? T as constant again by differentiation of this. So minus 1 upon 2 and t raised to n minus 1, we are keeping it as outside. Now we have to differentiate only r cube into e raised to minus r square upon 40 using UV rule, right? So firstly keep this as constant. So derivative of r cube will be equal to 3r square. Now keep r cube as it is and do the derivative of this. So derivative will be e raised to minus r square upon 40 and derivative of this will be equal to minus 2r upon 40. Now what you have to do is, you have to multiply this term with 1 upon r square. So on multiplying, you will get minus e raised to n minus 1 upon 2, 3 times e raised to minus r square upon 40 plus r into e raised to minus r square upon 40 into minus 2r upon 40. Now finally we will take out e raised to minus r square upon 40 common. So you will get answer as e raised to minus r square upon 40 minus 3 by 2 t raised to n minus 1 plus r square upon 4 t raised to n minus 2. We have taken this inside. So now what we have to do is, we have to compare the LHS and RHS. So on comparing, what you will get? Compare the two terms. You will get n as minus 3 by 2. Right? This is a very important sum. Now let's go to the next example. If x raised to x, y raised to y, z raised to z is equal to c, where c is constant, we have to show that at point x is equal to y is equal to z, del square z upon del x del y is equal to minus x log ex whole inverse. So let us begin with the solution. So we are given x raised to x, y raised to y, z raised to z is equal to c. First we will take log on both the sides. So on taking log, we will get log x raised to x, y raised to y, z raised to z is equal to log c. Now we have two conditions of log, that is log a b c, that will be equal to log a plus log b plus log c, and the next is log of a raised to b will be equal to b log a. So applying these two, we will get log x raised to x plus log y raised to y plus log z raised to z is equal to log c, and for the simplification we will get x log x plus y log y plus z log z is equal to log c. We will name this as equation 1. Now we will differentiate equation 1 partially with respect to x. Firstly, let me write our equation 1, that is x log x plus y log y plus z log z is equal to log c. Right? Now we have to differentiate this with respect to x. So what we will keep as constant? We will keep y as constant because z is a function of x and y. Now we will apply u-v rule firstly in this term. So keep u as it is and do the derivative of log x. So it will be 1 upon x. Now keep log x as it is. Do the derivative of x, that will be equal to 1. Now do the derivative of this term because the derivative of this term will be equal to 0 as y is constant. Again we have to apply u-v rule in this. So keep log z as it is, derivative of z will be equal to del z by del x plus keep z as it is and derivative of log z will be 1 upon z into del z by del x and derivative of log c, this is constant again, so it will be equal to 0. Now this x and x will get cancelled out. Similarly, this z and z will get cancelled out. So finally what we will get? 1 plus log x plus del z by del x into 1 plus log z is equal to 0. Now make del z by del x as a subject. So del z by del x is equal to minus 1 plus log x upon 1 plus log z. Now similarly we will find del z by del y. Just replace x by y. So what we will get? Del z by del y is equal to minus 1 plus log y upon 1 plus log z. Now let us begin with the LHS. So firstly we differentiate this with respect to x. So we are differentiating with respect to x, so we will keep y as constant, right? So del by del x of del z by del y, keeping y constant. So minus 1 plus log y will remain outside. Just do the derivative of 1 upon 1 plus log z. So we know the derivative of 1 upon x will be equal to minus 1 upon x square. So derivative of 1 upon 1 plus log z will be equal to minus 1 upon 1 plus log z whole square. Now using chain rule, the derivative of log z will be equal to 1 upon z and the derivative of z will be equal to del z by del x. Now just replace the value of del z by del x. So del z by del x is minus 1 plus log x upon 1 plus log z, and here minus minus plus and it will become 1 plus log y upon z into 1 plus log z whole square. Now further simplification we will get del square z upon del x del y is equal to minus 1 plus log y into 1 plus log x upon z into 1 plus log z whole cube. Now we will apply our condition, that is x is equal to y is equal to z, and convert this into x terms. So del square z upon del x del y will be finally equal to minus 1 plus log x whole square upon x into 1 plus log x whole cube. Now these terms will get cancelled out. So finally what will remain? Del square z upon del x del y is equal to minus 1 upon x into 1 plus log x. Now in order to get our desired answer, we will take this in our numerator. So it will be equal to minus x into 1 plus log x raised to minus 1. Now we will replace our 1 by log e. And we know that log a plus log b will be equal to log ab. So finally what we will get? Del square z upon del x del y is equal to minus x into log ex raised to minus 1. So this is our desired answer. I hope you understood all the three examples which are very important. Thank you for watching.